What's going on, everyone? Today's objective, I can create systems of equations from word problems. So we're just going to focus on the creation of the systems of equations. We've done a lot of work in the solving of the systems. So really main focus on creation of the systems. If you'd like to practice solving these on your own, I mean, more practice, always better. So your choice. I'm just going to talk about the creation. We will create and solve in class, though. All right, so let's dive right into it. First problem, and I'm going to ask you to copy all of these problems down so that you have them as references. Jeb and Lori went to a florist to buy flowers. Jeb bought 6 roses and 3 carnations for $20.25. Lori bought 8 roses and 3 carnations for $25.75. Find the price of 1 rose and the price of 1 carnation. Okay, so these types of problems, so different systems problems, are going to ask for different or give different types of details. This type of problem is a type of system problem where I'll say that there are 2 people, 2 companies, organizations, whatever the case may be. So the 2 things here, the 2 people here that we're talking about are Jeb and Lori. So that means that we're going to have one equation representing Jeb's scenario and the other equation representing Lori's scenario. Okay. Other piece of this is, what are our variables? Because we know that in a system of equations, normally we're used to x's and y's. If the problem doesn't specify a variable, we can choose our variable to be whatever we want it to be. So really, what is it that we're looking for? The price of 1 rose and the price of 1 carnation. So I'll use R and C. So R is going to represent the price of a rose, and C is going to represent the price of a carnation. So just to make sure that we have that information down. So this one's actually very straightforward. So let's go ahead and let's make the system. So let's deal with Jeb first. What did Jeb do? Jeb bought 6 roses and 3 carnations, and we know the total amount of money that he bought it for. Okay, so watch what I'm going to do here. 6 roses plus 3 carnations equal a total amount of $20.25. And that's it in terms of creating his equation. Lori's equation, very similar. She bought 8 roses and also 3 carnations for $25.75. And there's your system. All that there is to it. If you wanted to go ahead and solve it, well, this looks like a pretty good opportunity to use the elimination method, mainly because notice I have a 3C and a 3C. My variables lined up, everything the way that I want it to be, possible to solve. So we can go ahead and we can find the price of a rose and the price of a carnation the same way we would solve any system. All right, second example, the coins and dollars type of example. All right, this has come up on Regents exams before. Jason has $2.25 worth of dimes and quarters. He has twice as many dimes as quarters. Determine the number of dimes and the number of quarters that Jason has. Okay, so these take a little bit of thinking. So first, let's go ahead and let's identify what the 2 equations are going to represent. So there's only one Jason, right? So it's not going to be 2 names or 2 companies, 2 businesses, whatever the case may be. It's going to be 1 person. But what are the 2 units of things that he's talking about? Well, he's talking about coins, and he's talking about the amount of money that he has. So I'm just going to put a dollar sign, right? The number, he means, and what I mean by that is the number of coins and the number of, and the amount of dollars. So number of coins and amount of dollars that accumulates to. Okay, so we're going to put everything with each other. So let's think of it like this. What are my variables going to be? Let's go D for dimes. And let's go Q for quarters. Don't know why that was capitalized, but whatever. I did it anyway. All right. So let's do the money part. I think the money part is the easier part, and then the coins we'll think about for a moment. So how much, we have to think about this because it doesn't mention it here, but how much money is a dime? Well, we know a dime is 10 cents. How do I represent 10 cents? Well, that's going to be, no, I changed up my colors here, 0.1 or 0.10 times D. That'll represent the total amount of money I have in dimes, right? If I have 20 dimes, I would multiply 0.10 times 20. I don't know how much I have. Plus, what's the price of a quarter? Well, that's 25 cents, 0.25 times Q. And how much money is that equal to in total? $2.25. All right. So there's one equation right there just based on the amount of money. Now let's take a look at the coins. Now, what did they say about the coins? He has twice as many dimes as quarters. Twice as many dimes as quarters. So we ask ourselves, what does he have more of? Well, it looks like he has more dimes, right? Twice as many dimes as quarters. So let's represent that here. If I have twice as many dimes as quarters, then if I multiply my number of quarters times 2, well, that should be equal to the number of dimes I have. Okay, so that one takes a second. It always takes me a second to think about it as well. But that's what I go with, which one of these is greater. And this is usually how all of them are worded, or close to how all of them are worded. But this looks like a great opportunity to use the substitution method. So that's why it's good to know how to use both methods. All right, and last example. I know this is a long one, but please just have it in your examples. A paper company needs to ship paper to a large printing business. The paper will be shipped in small boxes and large boxes. Each small box of paper weighs 35 pounds. Each large box of paper weighs 65 pounds. A total of 22 boxes of paper were shipped, weighing 1,040 pounds altogether. Determine the number of small boxes shipped and the number of large boxes shipped. Okay, so I'm going to go through this one kind of quick. The two equations we're going to have is boxes and weight. And the weight in this case is in pounds. All right, what are my variables? Well, it looks like I can do S for small boxes, and is it large box? And large. So L, I'll go capital L for large boxes. Okay, so let's take a look at what's going on with the boxes. We have a total of 22 boxes, but we don't know how many of each. Well, this one's actually very nice. So that means that we have a certain amount of small boxes plus a certain amount of large boxes equals to a total amount of 22 boxes. Very nice. And our pounds, well, let's see what the pounds of each. Small boxes are 35 pounds. So 35 pounds times the number of smalls. I know my 5s and S's look alike. Plus 65 pounds times the number of larges is going to be equal to a total of 1,040 pounds. You could use elimination to solve, but there they are, creating word problems, creating systems based on word problems.